To my presentation, Practical DevSecOps. This presentation, I will try to have a very pragmatical and practical approach for this buzzword that is has been going around for quite a few months already. And I will try to explain my experience from the field. First things first, let's make an introduction. I am Julian. I am here because I like to deploy things fast and secure. And you can see there my Twitter ID. I am working for a bank in Amsterdam and as a platforms engineer lead. I have 7 years of fintech startups experience. I'm also passionate for about DevOps cultures and how to make an increased software engineering teams. A disclaimer from my side, since I'm working from a bank, these opinions are my own. Also, you will see a lot of vendors in the slides. I am not vouching and I'm not recommending them. These tools that I mentioned here needs to be re-evaluated and researched by the applicant to see if the applicability is okay for your system. So I'm not recommending. I use it at some point and they work well for my use case. So just do your own due diligence when you're using them. From my abstract, I think these days Agile is really not enough. If you really want to be a startup, a successful startup, and you want to prove that your product is good enough for the consumers, and you want to move ahead to the competitors, then you need to be really agile, for sure. That's a given, and you also need to transform towards the DevOps culture, but also, there are also always missing something. If you're in a high regulated environment, then these security practices will always come into your conversation. So this is really not there is no any time to avoid the security embedded in your DevOps. So I think it's time to have some stories from the field and share it with you guys. So if you are a startup or a product company, so I think you should be treating your DevOps team as another product team. And you should be planning using Scrum. You should be doing the ceremonies that Scrum advise. And then you should be delivering value in every single sprint. Then you will align with other squads or teams within your company. And this is very important because then you will probably see and synchronize with them in terms of security as well. And then you probably split the work as well. So this is very important. I think if you're doing Kanban, then I highly recommend that revisit that because it may not work that well. And in my experience, that when you're working well with the DevSecOps is when there is a product mentality within your DevOps team or practice. So this is really important, and this really makes the whole transformation work. Then you also during the years or during this last couple of months, you have been seeing different flavors of DevOps as well. So, but they always are probably missing something that we wanted to mention. Whether you're doing GitOps, that's trying to control your infrastructure from your repo, and is all towards like control and the top Kubernetes. Yeah, you need to be aware of the security of that practice. Whether it's DataOps, when you're doing all the analytics, moving a lot of data from one place to another, transforming it and making it useful in a beautiful dashboard, you need to be aware of the security in that as well, in that part of your data, moving things from A to B, and how secure is your data as well, and if you have sensitive data, or all of that. Whether you're doing machine learning ops, where you're trying to run models and trying to learn from that data, also need the security embedded there to check if you're not leaking information, for example, you're not evaluating sensitive information from your customers. Whether you're doing artificial intelligence ops, where the artificial intelligence will help you to process logs or identifying security threats. So security is also embedded there, could be embedded there, and shouldn't be missed. Or whether you're doing NovOps, where serverless enthusiasts claim it that, well, if you're doing serverless, you should do have operations. But I think there is a security aspect of it. You have to secure also your footprint of serverless. Or whether it's chat ops, where you are doing all your tooling, or the majority of your tooling is coming from your chat room. Very important that it also has to be security aware. So I will propose an agenda, very straightforward, 4 points, where we will try to define what is a DevSecOps, why it's important, and the implementation of it from my experience, and give some conclusions and final thoughts on the topic. Okay, let's try to define it. What is developer security operations? Well, in my opinion, it's just DevOps, keep it agile but secure. Really simple to define. But let's try to make it a more thoughtful definition. Borrowing from Ken, where he defines DevOps as a culture, obviously still a culture if you're trying to do the security part of it. But let's add the word secure. So people work together to imagine, develop, and deploy secure and operate systems. So just think, for instance, that if we are adding the secure, we're making everybody in our company aware of this. This is a very important insight towards this practice. If you want to make this work, everybody has to be aware of the security of your system. We can also try to define what is not. So what is not is when you leave security activities at the end of your life cycle. But everybody is trying to promise that's going to deliver the product or the feature at certain point of time. But what happened at the end is there is some delays because the security activities hasn't been performed. And then, well, there's always a huge friction there with why we forget those kind of things. So if you leave those security things at the end, there's always going to be a problem because people are not going to be happy not performing those things. And then the confidence of deploying the system to production, it will be a little bit less because they are not aware of the security posture of the system. So I think what is not is don't leave those things at the end of your life cycle. A good example is if you shift left all those activities very early days of your development life cycle, then if your stories are already embedding some security hints and the developers are also aware, product owners are also aware that they have to deliver some security activities, and DevOps team is also aware of these things. So the team will work together to make that happen, and it's going to be everybody's concern to think about security. A couple of practices I have been identifying during my work in highly regulated environments and trying to make this work are the following. Obviously, shift security activities to the left of your pipeline. When you're trying to automate your pipelines, I highly advise that the early, the better for security activities, because when you break the build the earlier, because they are not fulfilling certain activities, yeah, you need to help the developers to overcome those issues as early in the pipeline. So early days, the better. Early steps, the better. And increase the developer productivity and experience. So if you are choosing your tooling and vendors that are going to help you with the security activities, please make a conscious decision of checking if the features that they provide are good for the developers or for the whole engineering team. It makes their life easier or not. Then try to be helpful with them, because then if they create a friction, nobody's going to use it, or it's going to be hard to adopt those tools. And the third thing is to scale. If you have chosen your right security activities and automated them well, I think there shouldn't be a problem scaling them. So whether it's one team or many teams, then it shouldn't be a problem. If you have a problem, then you should reevaluate what sort of activity you have chosen, or reevaluate your tooling and vendors. So you can scale it better. Importance. Why is the development security operations important these days? It has some benefits. It makes the whole process end-to-end observable, and it's not just observing your system, it's observing your security traceability. Okay, how secure is your system in that early stages when they hit, for example, development? Can you check how secure it is at that stage? Can you check how secure is it at QA level? Can you check if it's secure enough at pre-production? And monitoring that in production. It's also easy to audit. Let's think about it. For instance, if you have been in an audit that takes a few days, if you implemented this well and automate enough these, you should be able to provide evidence for the auditors very quick. So instead of days or weeks of an audit, it should take 1 or 2 days in order to provide the evidence that they need. So it would be easy to find in the system evidence for a specific question that they will ask. And obviously, this will make the system compliant. And if you are in a highly regulated environment like finance or healthcare, yes, you need to be compliant with certain rules. And then this practice will help you to be compliant easier, because it will take those artifacts that they need or they're going to ask for to be ready for them in a time manner. Not when they ask, you should start collecting them. No, it should be ready for them in a timely basis. It also provides a unified governance. Once you're scaling, if you have already the governance in a small scale, it should work for big scale. So you start scaling your team to more than 1, 2, 3, or 4 squads, they should work. If you split it into products, they should work as well, because you have the same centralized view of your system and how to be in control of all of them. It should be frictionless. So this is one of the benefits. It should be painless. So the developers or all the engineering teams should be adopting this very easily. So you have to make the lives easy for them. So choosing, for example, a good practice from my experience, choosing the tooling with them together, so you can evaluate what sort of pain points they're trying to solve. And choosing also the vendor with them is very important. So they are all on board or choosing the right tools for the job. And obviously, one benefit is the cost efficient. So at this point, if you are adopting this practice, you should be driving the cost a little bit down, or you should be able to implement those security activities very cheaply or less expensive than before. Let's try to see an implementation of these with examples. I think this is one of the most important things. Instead of just giving a lot of buzzwords, a lot of things, let's see how I was able to implement this with my team in the past in companies I used to work. I'm just going to give here a use case where I will try to create or try to diagram the architecture that we use at that point of time, and what sort of tools we use to implement the activities that fulfill this successful practice. So the case of a study that I'm going to give you is a company that works in the payment industry, a startup, small team. So it's obviously highly regulated because it's fintech, so it's finance. They chose Golang as a main language to develop microservice architecture. And at that point in time, we chose EKS as our container orchestrator. Then the high-level architecture that we put together at the end was something like this. We have obviously our public cloud of choice, AWS. On top of that, we have our container orchestrator, EKS, and we were deploying microservices on top of it. But there were problems when we started. Okay, how we can guarantee that when you are joining the company, your identity is recognized across all the systems that we're going to have. So we start having this problem with IAM, like, okay, how are we going to manage identities in our company? And we chose, quickly enough, a provider that helped us. So this is the first vendor. It's not the only one. I'm not recommending it. We use it. It was good for what they offer. And basically what you're trying to look for here is the vendor should provide a really easy single sign-on for the tools that the SaaS that you're going to use and the tools that you're going to use. So if that vendor is helping you to integrate with other tools, that's good. And if it's easy to onboard people and also offboard people, if people leave the company, they also be shut down from all the other systems. So that is key for this. So you have to manage that very well. So a right vendor or the right tooling here will help you a lot. So Okta was the one we chose at that time, and it was giving a lot of good results, and we were basically fulfilling all the activities that needed for the IAM. The second one was choosing the right CI/CD provider. At that point in time, we chose GitLab, but I'm not saying GitLab is the only one. There are more. There is GitHub there, and it's maturing very quickly. I think one thing what we chose this for was because we were able to deploy agents independently into our AWS account. So, and we were able to secure them. And that's a big difference if the CI/CD tool doesn't provide agents, because then your security is basically outside. You cannot secure that actuator that is going to perform your pipelines inside your public cloud. So you need to secure a little bit more when you are in a highly compliance or highly regulated environment. But they're going to ask, oh wow, so the SaaS provider is secure now. Why is being hacked? So if you have the agent inside your cloud, then it will be ready to go and ready to secure that footprint. So we chose that at that time. That we also have a tool set for the infrastructure as a code. We use Terraform, a lot of Bash, a lot of Python to interact with AWS API. So basically, those tools or those languages were used in our pipelines to create pieces of infrastructure and deploy the microservices. We also had to choose what to do with the vulnerability management vertical, because when we started, security champions were asking, okay, what are you going to do with this? How are you going to check your code? How are you going to check your dependencies? How are you going to check your container images? How are you going to check your hosts if they are patched, if they have vulnerabilities? Wow, there's a lot of things to think about it. Then you need to choose this wisely. And at that point in time, what we decided to do was to choosing Twistlog as a vulnerability management and a runtime management for our footprint in production and in our pipelines, and Snyk as a complement to check dependencies and licenses and do a little bit of a scan in our code. So it was particularly difficult with this one because we, as I mentioned, we had Golang, and there are not many vendors out there, or not much tooling doing a good job for Golang scanning security issues. Then that was a very tough one, but I think we chose the right one. I think one of the other things that you have to keep in mind is when you integrate these tools in your CI/CD, they have to be they have to be quick as well. So if they start making your pipeline slow, then maybe it's not going to be good. So these tools were okay, not slowing down your the pipelines. So that's the reason also we choose them. For the monitoring vertical, we chose Grafana and Prometheus, and basically to monitor all the bits and pieces from the cloud that we were using, and the Kubernetes and the services. And for incident management, we chose PagerDuty. I believe this is one of the most mature in the market, and we were having a very good result with this in terms of our incident management. And last but not least, the logging. So Sumo Logic was the vendor we chose for centralized logging for everything, from the services to the Kubernetes control plane to the public cloud bits and pieces that we were doing. Sumo Logic has an incredible good feature that is basically providing apps for every single building block that you're probably going to use. So they have very well covered Kubernetes and AWS. So if you deploy those apps, you can automatically have a dashboard that can give you the visibility from those logs. So you basically provide your engineering team with a very quick view of what they have, and you can later on customize those things. Let's dig a little bit in the architecture to see what else we did with integrating the security into our DevOps team. Here is a common workflow that an engineer will do on a daily basis. Basically, we write a story, and when he starts creating the story, you create a feature branch to start working the story. He or she will commit some changes. And once he commits the changes, then we kick a build. There is a build trigger. And that build will check some security activities. So as I said, the earlier the better. So that's the reason here we have in green. So if you have it here, is probably one of the best stages where you can check this, because they are just starting with this feature. Then after that, if everything passes, then you produce an artifact. And then you probably create a merge request, as probably you are aware of. And then that merge request is being discussed in a peer review. And if it's approved, that particular feature is merged to the master. And another job is triggered in your CI. And it will check and it will do more strict checks in the security aspect. And maybe it will do more tests, it will do more stuff there. And at the end, your artifact is being deployed to the next environment. And in this case, it will be probably staging or QA. And you monitor your artifact to see changes. So here, your artifact will be a artifact that adds feature to the product, or it could be a piece of infrastructure, for example. Something like that is part of the cloud or is part of the Kubernetes infrastructure. So because we're using infrastructure as a code here, the flow will be the same, or is the same. So some of the activities you will perform in those jobs that are triggered by your CI/CD are, as an engineer, you probably have some linting and IDE plugins to check early when you start typing your code if it's secure enough, if it has good quality, it has good format, it has good naming convention, so on and so forth. You also can check secret management if you're not checking anything sensitive there. But you can move those activities also to your pipeline and check it there as well. So it could be double work. If the developer is quite new and is not used to this activity, you can embed it into the pipeline. So it would be better if the pipeline check for it and break the bill if something strange there. And it also will check static analysis. So it will check your code for vulnerabilities. It will also check your license compliance for open source libraries. For instance, if you are allowing only particular type of licenses within your company because there is a recommendation from high level, then check that policy. And you also check dependencies here. If you're using open source, this is really important because if you're using open source dependency, it would also check if that dependency has vulnerabilities. So it's really important here. So if this thing passes, then when you create your Docker container and push that to your registry, there is an image scanning activity that needs to be performed. And it's also checking for the layers of that container image to check how vulnerable they are, if they have a disclosed vulnerability in the public database. Then after that, when you deploy that container image to the next environment, in this case QA or staging, there is a testing activity. Whether it is integrated test to check if that container image is basically fitting in your other ecosystem of microservices, or if you have enough changes, then you will check your try to penetrate your system to check your security posture at that point in time. Once you're confident that is okay to go, or is doesn't something is not wrong there, you can promote that to production, and then you will start monitoring your microservice architecture or microservice ecosystem. That part from CI/CD to all the way from development to production is called vulnerability management, and that's very intense in the whole life cycle. So if you don't have the right tooling, if you don't have the right vendor for these, it will be a bit of a pain to implement it. Let's dig a little bit more how these all fit together. This is a common pipeline that I will try to demonstrate with all the vendors doing this activities in a very sequential way. So the developer will create a feature branch, and then we will, in that feature branch, we will trigger the linting, for example, CoSec here, just because we don't, well, we could trust the developer, but, well, let's do it again. If he hasn't performed or she hasn't performed these, then let's check it. Then Snyk, using the CLI tool, it will check dependencies and licenses. If everything is okay, then it will create a container image and push it to the registry. Once in the registry, Syslog will scan the image using the CLI tool. And if everything is okay, we will deploy to the next environment. Then we do integration tests to check if there is nothing broken in the interaction with other microservices. And when there is enough changes, we do a penetration test. It could also be a nightly build to check the penetration test at night after you have clear up your development work for the day. Also possible. But we do it when we had enough changes. So it was basically more fulfilling to check that delta of changes from the last time we did that. And after that, we deploy to production. And that's when the runtime kicks. The runtime starts checking, okay, the new container that you deploy is, instead of calling port 3000, it's calling the port 3010. And then it will probably alert on that. And then the operator will check, okay, is that normal? And then you probably check with the developers, hey, guys, is this normal? And they probably say yes or no. And also they probably check something like that. If the container is trying to elevate privilege, is this normal? They could raise an alert for this. And they also can check things like the container is trying to hit an API that is external to the public cloud and is going outside. So, and if it's okay because of the policies you have or the restrictions you have or the whitelisting you have, then it will say, oh, it's okay, but it will be logs there. So that's basically what the runtime does. And this is really important because it shows the security team that you are in control. And when they ask for evidence, you have it there. And if everything is logged, everything is being in control. And if there is an alert, you can decide if this is going to be an incident management and it's going to be performed during your SLAs within the team. So the other view that runtime will give you, that is very important for me and it's very easy to understand, is the vulnerability posture of your microservices. It can give you something like this, meaning that obviously green is okay, they don't have vulnerabilities, and if the color increases up to red, that's when you have to be worried about. In this case, for example, darker red means that they have critical vulnerabilities and they have to be fixed because they are highly exploitable. So basically you are exposed to those things. If they find that you are using that and they can exploit it, you're probably going to be hacked. So better to fix it as soon as possible. So the lighter red has some high vulnerabilities, then you need to check there. Orange and yellow, medium and low. So they are okay. So they are not high in a score in a CVE score. So you could probably have to have some time to fix them. But yeah, I think the holy grail will be to basically create everything green or make it green. And that's basically my experience in a summary. I hope it was good enough and the explanation was good enough with the tooling and the vendors that we use at that time. And just to wrap up the presentation, I have some final thoughts, conclusions on learnings from this. I think since I was implementing this, so we learned some things. At the beginning, try to avoid tooling and vendor help. Well, you start probably trying to have several tools that are in the open source or pay or not, different vendors that offer probably a particular feature you're trying to address. but then at some point you're going to end up with too many, and then for a small team, it's very hard. Even for a big team, I think you don't want to know if you have 100 tools to address all the security activities. You don't want that. So for that reason, we tried to simplify. So we had a simplification exercise, and it went quite well. So we tried to reduce the amount of tools that we use and trying to refactor. If one tool was doing the same thing, then we're trying to put that into. It was a good exercise, and I think we did a quite good work. So we increased the developer experience because the developers were engaged from the early days of the decision process. They were okay using those tools, and the adoption rate and the usage basically increased dramatically. And they were completely fine with going to the dashboard of the tools that we chose and fixing their own issues themselves. It was very exciting seeing those things happen. Well, we achieve security as a code. It's possible. So security, and if you write your policies right with the declarative code, you can achieve this. So you can review it in your merge request, and you can see security champions interacting with you on those things and giving some advice, which is very great. So at that time, reviewing your merge request and they're giving you, hey, don't let this port be open for reason, and try to log this more and something like that. At that early stage was very good, because we were trying to address that at that time. We also had compliance as a code. Compliance as a code as well. We tried to put some policies in place, so we were able to wrap up the compliance in our code as well, and we were able to produce meaningful reports for the time when the time of the audit comes. So we were already ready for that, and we were able to reduce the costs. As I said, we tried to simplify our tooling footprint and vendor footprint. We were also reduce the cost, and as well, you need to be very aware of what's going on in the security space with all the tooling and vendors that you are using. Why is this important? Because sometimes your cloud provider will develop the feature. Sometimes a vendor is being acquired by another one, and then you need to start checking if if the feature set is going to be the same, how the cost is going to be affected here, how you can save money. You need to basically check how you can save money all the time here, because those security products, if you are choosing a vendor, they are not cheap. So better to make a deal, very good deal at the very beginning. And if the situation has changed because they have been acquired or they have been merging with another company, check if you can have even a better deal. It's a good advice from me, because sometimes they just start and don't say anything, and you keep paying the same amount of money, and then they actually increase the set of features, and they have been changing the way they operate and the way they pricing you, or the way they're pricing new clients. So you have to reevaluate those kind of contracts every time there is a new move in the market. So those are my takeaways from this journey. I hope you liked my presentation. I hope you learned something new today. Please stay in touch using Twitter, or just using the hashtag NextOps, where I try to see where is this going to end, where is going to be the next wave of this in this hashtag. Well, thank you. I hope you like my presentation. I will be in a slide answering questions. Bye.